Drafting improvements in ZW3D 2014 includes direct edit view, customized components section state, grid edit of dimension, auto centerline generation, new tolerance zone and fit tolerance. Take an example. Create a 2D sheet. First, we have a standard view. Then, to create a section view, choose the center of the holes as the section points. Drag and drop the section line or base point and the section view will update in real time. Modification is easier than ever. If you want to add a new step point, just right-click on the section line and insert the step point. Drag and drop it to change the position. Changing the section direction is also very convenient. Sub-objects of view can't be deleted or moved. You can blank it or assign it to another layer. By default, the section view can only be moved along the section direction. Uncheck the alignment option to move the section view to any position. Recheck the alignment option and it will be returned to its original position. Create a standard view again. The new feature, Rotate View, provides an in-place edit function specifically for base view. Let's see the second point, Customize Component Section State. This is a reducer assembly part. Create a 2D sheet. First, create a front view. Next, get a full section view. There is a new section option. You can set the section state for each component. This is the first method. Another method is to set them in Sheet Manager. Generally, a shaft part doesn't need a section in view. Try again without including the bearing part. The view is updated quickly. 2D sheet edit is more efficient. Let's see some other improvements. When creating views, the center lines are automatically generated. Some dimension features are improved. Editing dimension attributes will result in new tolerance zones. The value can be entered manually or attained from a table. Add a fit tolerance for an assembly view. Firstly, create a diameter dimension. Edit the attribute and select the fit tolerance. You have shaft fit tolerance and hole fit tolerance. Select the one you require. The whole operation is very intuitive. Lastly, let's see how to quickly redefine the dimension with the grid edit function. Firstly, create several dimensions as an example. Pick the dimension and some grip points are displayed. Drag and drop any one of them. You can modify it directly. The value is updated. Grip edit is a highly useful feature. Any modification of dimension elements becomes more efficient. Feature frozen. This new feature is very useful for any part with many modeling steps or complex geometry features. Activate it in the Configuration menu, and it is shown in the History Manager. You can easily drag and drop the feature frozen bar to any position. Operations before this bar in History Manager are frozen. This means users can't edit or delete them, preventing unexpected model changes. Another important point is that it greatly reduces the history regeneration time, since each regeneration is started from the frozen bar. Throughout the design, Feature Frozen provides better feature management, especially for complex parts. In-place editable table. Create a BOM table for the reducer assembly part. Use the top left corner to move the table. Click this corner cell to activate the edit function. Easily insert another row or column and assign the column property. Table information is automatically updated. Select any column or row and you can delete it directly. Position adjustment is also very convenient. Left, right, or center. Double-click on the column title to change the item. All available part attributes are listed here. Select your required part. Click any cell and you can edit it directly, such as add descriptions for certain parts. Part 1 is a shaft. Part 7 is a bearing. Add another property. Part material. Get all part material information from part attribute. Modify the big shaft material. 42 CR. Next, let's synchronize the BOM table with part attributes. Go back to modeling to check. This is the big shaft part. Check part attribute. The material is updated. 42 CR. The upgraded table functions allow you to work intuitively, just like Excel. Part configuration. Part configuration allows designers to easily manage the status of a variety of different parts. Firstly, let's create a part configuration and give it a name, No Counterbore. Double-click to activate it and edit. Add the features Hole 1, and mirror one. Check it to suppress. This is the result without counterbores. Create another one and name it Big Bass. Activate, then edit. Uncheck these since no features need to be suppressed. Add the Block 1 feature and its dimensions are available. In this table you can modify them directly. Let's check it. Next, a 2D sheet. In the Advanced table, part configuration can be set. Quickly get other projection views. Create another 2D sheet in the same file. Now you can get views with different part configurations. It is very convenient. Next, let's see how to use it in an assembly. In Assembly Manager, right-click the component and you can directly assign the part configuration used on this assembly environment. Toolpath editor tools in ZW3D 2014 include toolpath trim, reorder, relink, extend, and many more. Take an example. Here is a runner. A few toolpaths are cut into this area, but for a better machining effect, these cuts are not wanted. We can use the trim function to remove them. Using polygon select to define the trim area, middle click to trim the toolpath. After trimming, we can also use the relink function to get a continuous cutting tool path. Set suitable link parameters. Now get the perfect tool path. It's very convenient. Let's see a third feature, toolpath extend. Here, the programmer wants the toolpath extended to get an improved machining effect. Select the Extend command to achieve this. Give a distance value, then select OK. Let's go to the next section to see toolpath reorder. Firstly, use Solid Verify to check the sequence of the toolpath. You can see that the cutting sequence is from right to left. According to machining process, we need to adjust the order from both sides to the middle step by step. Pick the reorder command. Select a toolpath and send it to the bottom one by one. This ensures machining balance throughout the process. Once you're finished, let's use Solid Verify to check the results. The optimized toolpath will produce much improved results. With Toolpath Editor, we can quickly get better toolpaths without adjusting the complex parameters, drastically saving recalculation time.